A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, good evening to all of you, and welcome to Baiju's Exam Prep IS. Welcome to another session of geography here. Today, we shall be continuing our discussion about air masses, fronts, and the types of cyclones from where we left off yesterday. So, in this particular chapter, what is it that we had discussed yesterday? We had discussed what do we understand by air masses. There, when we talked about air masses, we actually observed that air masses are nothing but a large homogeneous mass of air having uniform property of temperature, vapor, or humidity, etc. That is what is referred to as an air mass. Then we also discussed the fact that after the air spends a considerable amount of period over any particular kind of a surface, the air gains the property of that surface. If the air spends some amount of time over the desert areas, the air tends to become drier. And if it is a hot desert, it tends to become warmer. Then the air, if it spends some time over the polar regions, it becomes frigid, very, very cold. So, those particular surfaces from which air gains its property, those are referred to as the source regions for the air masses. Those are known as the various different source regions. Then after that, we looked at the nomenclature and the naming of the air mass, where we observed that the air masses, they are named accordingly based upon if they are dry, you associate the name continental or sea. And then based upon or if they are moist, they are put with the name of maritime. And then after that, depending upon whether you find it in equatorial, in tropical, in polar, in Arctic, or in Antarctic region, the air masses are accordingly divided. Now here, we also looked at the fact that why we only have a maritime equatorial air mass, we do not have a continental equatorial air mass. And the reason behind them being that around the region of equator, you first of all, you don't have significant amount of a land area. And whatever land area does exist, there the amount of moisture in the air will be so very high due to everyday occurrence of convectional rainfall at the equator. That is why it will always be a kind of a moist air mass which shall be observed in those areas. So that is something that we observed. Now, after that, we started looking in the process or the formation of fronts, where we observed that when we talk about fronts, these are basically zones of transition. These are zones of transition where you have the bordering region between a warm air and a cold air. That is what we refer to as a front. Now, for example, if we take a look at the map here, we observe that warm air and cold air, they don't form a straight line. Rather, they form a kind of a wave pattern, which means in certain areas, it is the cold air, which is very penetrative. In certain areas, it is the warm air, which is significantly penetrative as well. So, in certain areas, the warm air enters into the region of the cold air. In certain areas, the cold air moves into the region of the warm air. So, wherever that zone of transition is achieved, that is where we say that a front is formed. The process of formation of a front is what we refer to as frontogenesis. And the dissipation or the death of the front, what is it referred to as? Do we remember? Yesterday we discussed what is the dissipation of the front referred to as. Very good. It is frontolysis. Frontolysis basically means that you don't have that zone of transition, that difference anymore. Frontolysis basically indicates that you only will have the uniform kind of air mass which is going to be prevalent. Now, here, that is what we observed in the case of the air mass. Now, we also looked at the process of formation. Now, these air masses, in which particular season will you experience much greater frequency and intensity of frontogenesis? In which season? In the winter season. Very good. So, when we talk about frontogenesis, I hope we are all convinced with the reasons why you have more formation or more occurrence of frontogenesis in winter. That is because there's a greater difference of temperature between the warmer and the colder air mass. So here, frontogenesis occurs in winter. More frequently and prominently during winters. Okay, during the winter season. Now, if I ask you that where is it that you will have this frontogenesis occurring more frequently, across which portion of the earth? Will it be across low latitudes? Will it be across mid latitudes? Or will it be at around 70, 80 degrees? Where is it that you will have a greater probability of the frontogenesis occurring? What do you think? Beautiful. It will be the mid latitudes. Mid latitudes around sometimes from 45 degrees itself, sometimes up till 65 degrees, north and south. That is where frontogenesis is more common, going to occur more in mid latitudes. And when we say mid latitudes, it is going to be roughly around 45 degrees to 60 degrees or 65 degrees north and south. Now, even this particular front that you observe, the front formation that you observe, where on the ground surface, if you consider, you will have the cold air mass. Cold air mass will always have a lesser volume, and then you will have the ever expansive warm air and the cold air. So, it can sometimes happen that, let's suppose the cold air and warm air, they have come head to head, but none of them are moving in either direction. That can also be a front. Then sometimes it can happen that cold air keeps on pushing towards the region of the warm air. Sometimes it can happen that warm air pushes into the region of the cold air. Sometimes it can happen both of them will move. So there is a classification of the front into four different types based upon which of these events do take place. So when we talk about the types of front, you have four different types of front based upon this property of the movement of warm or cold air. You have the stationary front. Stationary. The name in itself is descriptive about it, that it is not moving, it is static, right? So that is a stationary front, where let's suppose the cold air has come to a particular area, warm air has come to a particular region. None of them have got enough energy to be moving into each other's territory. They are static wherever they are found. They are found to be very, very static, right? So that is the case of a stationary front. Then you have a cold front. Cold front is basically where you will have movement of cold air. Of cold air mass, where the cold air mass enters into the territory of warm air. That is basically the case of a cold front. And then you have the warm front, where basically you have movement of warm air mass into the region of colder air. Then you have what is known as an occluded front, which generally occurs just before, sometimes during the case of a temperate cyclone, when the front is about to close from all different directions. That is when you observe the creation or the formation of an occluded front. I will show you with the help of the image also, with the help of the image of a temperate cyclone, that when do we experience that occluded front and what is that occluded front. Occluded is derived from the term occlusion, which means closing. So a front which starts to close, so that is an occluded front. So what do we mean that a front begins to close? So we will study that. So let us take a look at each of them one by one. Let us try to understand the weather conditions associated with each of these fronts, the type of rainfall associated with each of these fronts, and their details also. So first of all, stationary front. Stationary front is when the air masses of different properties, they have come head to head. They have come in front of each other. But neither of them has got enough energy to be pushing into others' territory. Okay, so you can imagine that air masses, let's suppose the cold air has come up till this extent, the warm air has come up till this extent, but none of them have got enough energy to move into others' territory. Now, what do we mean? None of them have enough energy. Is it something that they work on fossil fuel, that provide fossil fuel, they will get energy? Where is it that this air masses gain their energy for movement? What do you think? Where is it that this warm air mass will gain its energy in order to move into the region of the cold air? Which will be the driver of that energy? Think about it for a brief moment and let me know. I want a bit of a precise answer. So think about it. What is the driving force which can push the warm air into the region of the cold air? Coriolis force in itself cannot lead to the movement of the winds. They can lead to the deviation of the winds. Very good, Vibhu. Perfect answer, my dear friend. Again, I will frame the question. One of you have given the correct answer. Till now, only one has given the correct answer. Nikhat, think about it carefully again. You are roughly around the answer. Where does the warm air gain its energy from in order to move into the region of cold air? It is not pressure gradient force. Many of you have written pressure gradient force. I am asking a specific question. Where does, so the answer that you are giving is the answer for where does the wind gain its energy from, right? But that is also not correct answer in that. So what is the source of that energy? At least one other person if gives the correct answer. Prem Kumar, you are slightly moving in that direction, but still it is incorrect. Equatorial low actually attracts the winds. It doesn't provide the winds, right? What is the source? Very good, Shreyas. Very good. Now we have the correct answers coming in. Meghna, correct. Shreyas, correct. Likhani, correct. Very good. So it comes from the portion of subtropical high pressure. Very good, Bhima. So from the subtropical high pressure belt, you do get these warm winds from. It is from these subtropical high pressure belts. So stronger the subtropical high pressure, more will be the winds being pushed towards the higher latitude and also towards the equator or the ITCZ. Weaker the subtropical high pressure belt, weaker will be the movement. Okay. So Likhani, Shreyas, Vibhu, Meghana, very nice. Good. And on a similar note, where is it that the cold air gains its energy from that drives the movement of cold air? From where does the cold air gain its energy from? Good. All of you should get it correct. It is the polar high, the high pressure belt at the polar region. So that is basically the case of the movement of this air. Now, let's suppose these air masses have come head to head in front of each other, but then the pressure centers which are driving them, they are not very strong enough to drive them any further. That is when they will lie static in the same place. They won't be indicating any kind of a movement. Okay. Now, it might happen that maybe after a couple of days, or maybe 2 to 3 days or 4 days, maybe the cold air gains some energy and pushes into the region of warm air, or vice versa might also happen. Then the stationary front will get distorted. If the cold air enters into the warm air region or the warm air enters into the cold air region, that stationary front will then be distorted because now there is movement. It can also happen sometimes that there is no movement. There is no movement. None of them have gained enough energy to be moving into each other's region. They lie static for around 2 to 3 weeks. Now, when they lie static for around 2 to 3 weeks, what will happen? In the same area, the air masses, they are confronted with each other and they are static. Eventually, basically, the cold air will gain some property of the warm air will gain some property of the cold air, and there will be a kind of a homogenization. So when that homogenization happens, that is the dissipation of the front. That means there is no longer that zone of transition which is present. Frontolysis will be observed. So in case if the air masses continue to remain static for around 2 to 3 weeks, they mix and eventual dissipation of the front is observed. That dissipation of the front we know by the name frontolysis. Okay, that is what we refer to as frontolysis. Now, this is the case of a stationary front. So in the case of a stationary front, if let's suppose you are an individual standing here, Obviously, it is a very large area where this front is created. Let's suppose you tend to move from one place to another. You will experience a sudden change in pressure. You will experience a sudden change in temperature as well, right? That is something you will experience as you move maybe from a warmer air region to a colder air region or vice versa. There will be that sudden change in temperature and pressure which will be observed by you. So that is the characteristic that you observe in the case of a stationary front. Now we come to what is known as a cold front. Now, what is a cold front? In the cold front, it is the cold air which is much more active. The cold air is significantly more active. Let me get a piece of paper so that we can have the appropriate understanding, analogy of it. Just a moment. Okay. So, in this case, the cold air is the one which will be much more active, and the cold air pushes into the region of the warm air. But we do know that cold air is slightly or significantly compressed. It is not expansive like the warm air. The cold air is compressed. Compressed means it has got restricted volume because in cold air, the particles will be closer to each other. So here you have cold air. Here, let's suppose you have the case of warm air. Right? Cold air which is active, which is moving in. What will happen to the warm air? So listen to this very carefully. So suppose this piece of paper represents the volume of the cold air, and the cold air is moving closer to the surface. Let's suppose here you have the expansive warm air. Now, as soon as the cold air comes and hits, where does the warm air go? It is lifted vertically. The warm air, observe, as the cold air comes, the warm air will be pushed up vertically. Are we comfortable with this? That cold air being the heavier one, it will stick closer to the ground surface, it will come, and then it will straight away vertically end up raising the case of the warm air. Comfortable with this particular assumption? Yes? Okay. So in this case, as the cold air pushes into the region of warm air, the warm air is vertically pushed upwards. As this transitions, as this progresses, let's suppose we talk about this cold air. As it transitions and progresses, the warm air is lifted up vertically. Now, pay some attention and listen to this carefully and try to use your logic. When you have an air mass or any air parcel which is vertically lifted up, straight away vertically lifted up, then can we say that condensation will happen in the same place at various different levels? If in the same region the air is vertically lifted up, can we come to the conclusion that condensation or cloud formation will happen at the same place at various vertical levels? We can come to that conclusion. Now that will lead to what cloud formation? When the cloud formation happens in the same place at various different vertical levels, the cloud is vertically very well developed. What kind of cloud formation will be observed there? Very good. You will have cumulonimbus, which is very thick and vertical. So that is where you will have cumulonimbus. Some cirrus clouds will also be formed because of the fact that you have the warm air which tends to rise up, and in that area, if the warm air rises up, you will have some very high altitude clouds also. But majorly, as an outcome of this vertical rise, the vertical rise of the warm air vertical rise of warm air leads to formation of cumulonimbus clouds. Now, what will be the weather associated? First of all, here, very heavy and violent rainfall, and violent rain with thunder and lightning. Then, after this, can we experience a temperature inversion here, a frontal inversion? Frontal inversion means less mixing of air masses, of air mass. Okay, so this is basically, Vikram, just wait for 5 minutes, you will understand. So this is basically the case where as the cold air pushes in here, which is an example of the cold advection, now there the warm air is almost lifted vertically because the cold air simply enters into the region or the territory of the warm air. So the warm air is lifted vertically. And that brings about the condition of an inversion. That brings about a condition, when we talk about it, of cumulonimbus cloud formation with violent and heavy rainfall. Now, the opposite of this cold front is a warm front. By the way, when will this cold front occur? When you will have the polar high pressure to be very strong. The regions of the poles, when they are very, very cold. So that is when the mid latitudes around 50 degrees, around 60 degrees, they will experience very heavy amount of rainfall because of the formation of a cold front, where the ground surface temperature suddenly reduces. Because let's suppose you are an individual standing here. Let's suppose. Earlier, you were experiencing a higher temperature, but as the cold air has come forward, suddenly the temperature has dipped. And to add on to that, you have heavy amount of rainfall along with significant and substantial amount of thunder and lightning as well. So that is basically what you experience in the case of a cold front. Okay, so sudden reduction of temperature. Yes, Prerna, we can have that. Sudden reduction of temperature due to cold advection. Okay, are cloud forms as they reach the saturation level when cold air comes into contact? See, when is it that air will reach the saturation level? When it cools down, isn't it? So when will it cool down? Some of it, if let's suppose it is heavily moisture laden, it can cool down immediately by contact with the cold air itself. Some of them will cool down as it rises up or as it is pushed up further at a height maybe of 3 kilometers or 4 kilometers. So both the impact can lead to condensation. Yes, Dikshit, it will. Now, the opposite of it is a warm front. In the case of a warm front, you have something quite contrary to it where the warm air advances. Now think about it, this is the cold air. Now the warm air is coming in. The warm air is coming in. It is coming in this area. And then it moves into the region of the cold air. Will it be able to lift the cold air from the ground? No, cold air is heavier. So what will the warm air do? Warm air will slowly and steadily start riding up like an inclined plane. So the condensation which will happen across this entire incline. Over a large area, this condensation will happen. So which kind of clouds will dominate? When you have condensation spread over a large area, which kind of clouds will be dominant? What do you think? Stratus kind of clouds. Very good. So you will have nimbostratus, altostratus, stratus in itself, cirrostratus. They will be very, very dominant. Okay. Frontal inversion. Have we studied about the temperature inversion, guys? About the types of temperature inversion, have we studied? Yes? Okay. Everybody is saying yes, only GIB you are saying no. So either you missed out that portion or you were zoned out at that point of time. So when we talk about the temperature inversion, you have different types that we studied: surface inversion, subsidence inversion, frontal inversion, and valley inversion. So you have four different types of inversion. Frontal inversion is when there is a front formation, cold air and warm air, when they interact, the cold air will stay at the bottom, warm air will come to the top. And that is when you will have inversion, right? Okay, fair enough. Now, the warm front. In the case of a warm front, here, it is the warm air which has gained significant amount of intensity. This is your cold air. Yes, correct. GIB. And let's suppose here you have the expansive warm air. Now, as this warm air comes in, eventually, this particular warm air will slightly rise up this incline. I hope you are able to visualize this. It will rise up above this incline. It cannot displace the cold air from the ground surface because the cold air is very, very heavy. So the warm air would have reached here. Okay. Now, in this case, the cloud formation will be distributed over this entire region, right? So here you will observe formation of stratus types of clouds because it is spread over a large area. In the case of a cold front, it was rising up vertically in the same area. Clouds. So, one of you had asked the Vikram. You had asked the question. Vikram, is it clear now? Stratus types of clouds. So, the climate associated. What is the climate associated with this type of cloud? Can we consider that? Or can we take a guess about that? I hope we should be able to get that answer. Very good. Rains and drizzles, moderate rain. Good. So in this case, whenever you have, yes, whenever you have stratus cloud formation, you will observe that it will drizzle, it will rain, light to moderate rainfall for a longer duration of time without much of thunder and lightning. So light to moderate rainfall. Rains for a longer duration. Yes, Rani, correct. Along with fog, mist, etc. That will also be there. Will there be an inversion condition in this case, or will the inversion condition not be observed? It will be observed. Very good. Frontal inversion. Then other than that, you will, the other things that you will observe, we will study after some time. Basically, this is the case of a warm front. This is the case of a cold front and a stationary front. We have seen all of them. Now, before we move into the case of the occluded front, I want you to visualize something first. Now, it means fronts also cause inversion? Yes, absolutely. Let us consider the formation of a front from a top view. Let's observe the top view. Now, it can happen that earlier you had a cloud form. You are looking at it from above. Okay, the warm air and the cold air, they are interacting, and you have a view from above. So always understand that. Let's suppose this is the region of cold air. This is the region of warm air. Now tell me one basic thing, one simple thing. Whether it is a cold front or is it a warm front, will we experience rise of air? Yes or no? Whether it is a cold front or a warm front, will we experience rise of air? Yes? No? Okay. Yes. Because in both the cases, we have seen that in first case, in the cold front, you have almost a vertical rise. In the second case, we see that there is a slanting rise, but a rise nonetheless. Now, when there is a rise of air, on the ground surface, what is the impact on pressure? Is the pressure going to increase? Is the pressure going to reduce? What do you think? Beautiful. Anjan, why? Why do you think? Again, listen to this carefully. Whenever there is a rise of air. So earlier you had cold air and warm air. Regardless of whichever is moving, there is some amount of air which is rising up. Whenever you have rise of air, that means on the ground surface, always the pressure is going to reduce. Okay, so understand this. So basically, be it a cold or warm front, there is going to be a rise of air. A rise of air creates low pressure. Are we comfortable with this particular fact? Cold fronts are rising. See, it is not the front which is rising, my dear friend Ankush. It is never going to be the case that the front, what is a front? Front is a zone of transition. Front is that area where that transition is created. How can that area in itself get lifted up? So it is the air which gets lifted up. Mostly it is the warm air. Warm air, along with it, sometimes as it rises up, due to the frictional drag, it will end up dragging some amount of the cold air also. But mostly it is going to be the rise of the warm air associated. Because of the frictional drag, You might have some of the cold air also which is rising, but nonetheless, it is going to indicate a rise of air. Now, rise of air mass or air parcel, wherever it happens, it reduces the pressure on the ground, creates a condition of a low pressure. Comfortable up till now? We saw warm air is rising only either vertically or slant manner. Cold air isn't rising. That is true. Cold air, because it is heavier, doesn't rise so much. But as the warm air rises up, it brings along with it. Imagine if you have this cold air and the warm air is rising up from here. So the frictional drag that the warm air will create, that will end up raising some amount of cold air along with it. So that is why eventually higher up, you will observe both some amount of warm and cold air to be rising. But closer to the ground, it is mostly the movement of the warm air. Along with it, it might drag some amount of cold air as well. I hope it is understandable to everybody. Will not cold air comes in, so making the pressure increase? I'm coming to that. I'm coming to that. Now, this creates a low pressure on the ground. Now, we do know that whenever you have a condition of a low pressure, can we say it attracts winds from all sides? Low pressure is the attractor of wind because winds always blow from a high to a low. So, what does this mean? So, here, listen to this carefully. Cold air tried to move into the region of the warm air, and thereby there was a rise of warm air. Warm air tried to enter into the region of the cold air, and there was a rise. So, can we say that in this area, there will be a low pressure? This doesn't happen most often. This is something which doesn't happen very frequently. This is something which happens only when the front continues to get distorted and distorted. Otherwise, under normal circumstances, it can also achieve frontolysis way before, even during the time of the cold front or warm front or stationary front, it can attain frontolysis. But sometimes you will have that significant and substantial creation of low pressure. So low pressure means more cold air will be driven, isn't it? More warm air will also be driven. There is a rise of air, mostly warm air. So what will happen to the shape of the front? Near the ground surface, it is the cold air which remains. Now again, the time to take a look at the paper. Suppose this is the shape of the front, slightly inclined because cold air is having lesser amount of a significantly lesser amount of volume. So let's suppose here you have the warm air, on the other side you have the cold air. Now, as more air starts coming in from all directions, you will observe that the cold air continues to remain on the ground and basically warm air gets completely lifted up. So think about it again. As more air gets pushed towards this region of low pressure, be it a warm front or a cold front, cold air will remain on the ground. It is always the warmer air which will tend to rise up. Some amount of cold air will also be dragged, but mostly the warmer air which will rise up. So on the ground surface, will you have warm air anymore? No. The cold air will stay on the ground. So as the cold air progresses, what do you observe here? Can we say that the front is closing in around that region of low pressure? Can we say that from all sides, as the cold air comes closer to the ground, the front starts to close in? Will that be a correct assumption to make? Good. So that is what is observed. Eventually, this front starts getting distorted. Because be it a warm front or a cold front, it is the cold air which stays on the ground. Again. cold air stays on the ground as the warm air rises up. The front gets distorted, and begins to close up. And that is a closing front or an occluded front. So this front will keep on getting distorted more and more. From all sides, it will begin to close. The cold air will begin to close the boundary here. Eventually, what you will have is the case of the colder air and gripping the entire area near the ground surface. This is the case of an occluded front. Now, after this, when the cold air has basically replaced everything near the ground surface, what do we observe? I will show you with the help of an image. So what you observe here are the various different stages of a temperate cyclone. Okay, so what we need to understand as of now, what we need to observe as of now, we don't need to get into, we will get into the details of the temperate cyclone formation. But we do need to observe right now is observe how the front starts to get distorted. There's a low pressure center around which more winds will be attracted. Observe how the front starts to close. This is basically the occluded front. Now, this was the region where the frontal formation occurred. Observe this area. Mark this area. This is the region where the front still exists. Now, what happened to this region where the front was formed? Can we say occlusion of front can eventually lead to frontolysis because now you only have cold air near the ground surface. You don't have that zone of transition anymore. Can we say that occluded front can lead to frontolysis eventually? Can we say that? Yes? Ankush, is that understood now? Good. So that is the case of the occluded front. Eventually can lead to frontolysis. Okay? Eventually, it can lead to frontolysis. Right? This is one portion which you will find it very incredibly difficult. Along with the temperate cyclone, this is one of the areas which is incredibly difficult to grasp if you read any book. An individual who you can basically find out any type of books there available in the market. Always this occlusion, the temperate cyclone format, that is something very impossible to fathom because in a two-dimensional or in a written format. That is why I would always advise you, whenever you have doubt in this, if you're reading the NCRTs while carrying out revision, maybe 5 months down the line or 6 months down the line, if you still have any doubt in this, kindly open up this particular recorded lecture, look at this, and then try to understand what is that occlusion. Okay, occlusion or the occluded front is when the front closes around the low pressure. So closing of the front around the region of low pressure. So it is not the case that always when a front is created, there will be warm front, cold front, occluded front, all of them will happen. That does not happen always. You can always come across a scenario where initially, when let's suppose there is a frontal formation, maybe from the stationary front itself, frontalisis can happen. It sometimes can happen that, okay, a cold front has been created, it has caused thunderous rainfall in an area, the region has become colder now. Now there is no longer that transition of temperature anymore, so frontalisis can happen. It can also happen that warm front is created, warmer air is active, eventually frontalizes. Only in certain cases do you observe the entire deformation of the front to lead to the eventual occlusion of the front as well. Okay? Now, then we come to the larger issue or the larger topic of cyclones. Now, this is going to be an area of key interest when it comes to UPSC. Now, here, first of all, what do we mean by cyclones? What is a cyclone? Cyclone means a circular upward movement of air. That is a cyclone. Why will there be a circular upward movement of air? Because of very intense low pressure system on the ground. Not a normal average low pressure that you see on a day-to-day basis. A very, very intense and extreme low pressure condition formed on the ground in a small area, not across a pressure belt, in a small area. So what will that mean? Let's suppose you have this region having low pressure. So air will be attracted from all different sides. And then the air will start to rise up. Right, around this area of low pressure. So cyclones are regions of very intense low pressure. Okay. Now, these very intense low pressure or very extreme low pressure, either of them, they can be formed due to different reasons. They can be formed due to thermal condition and they can be formed due to dynamic condition. Now, in lower latitude, closer to equator or closer to the tropics, which is more likely to be created, a thermal low pressure or a dynamic low pressure, closer to the lower latitudes? What do you think? Very good. A thermal low pressure because of heating around the mid latitudes, which will be more prominent? A dynamic low pressure or a thermal low pressure around the region of the mid latitude? Dynamic. Very good. So low pressure can be created because of different reasons. Accordingly, the type of cyclone which is created, they will have very different features, phenomena, property associated. So here we are going to study two types of cyclone. One is what we refer to as temperate cyclone. In the temperate areas or the region of mid latitudes, and another is the tropical cyclone. Which is created in the region of the lower latitudes. India gets impacted mostly by the tropical cyclones. Both their formation, features, properties, movement, types of rain caused, dimension, everything is completely different from each other. Majorly, other than the common unifying factor that it is created around an intense or an extreme low pressure. Okay. But before moving into the details of a temperate or a tropical cyclone, let us spend some amount of time in order to understand the generalistic aspect of what is this intense low pressure. What is this cyclone? Now, by the way, just like you can have an intense low pressure condition on the ground, can we expect an intense high pressure condition on the ground also? Now, in the case of a high pressure condition, you will have air which is sinking, and then diverging into different areas. So it is simply the opposite of a cyclone. That is what we refer to as an anticyclone. So let us understand. So the wind circulation around a low pressure is called a cyclonic circulation. Around a high pressure, it is known as anticyclonic circulation. So here, observe this anticyclonic circulation first. Observe that around the region of this high pressure, the winds basically, they move down. They might get heated, adiabatically heated by the time that they come to the ground surface. But there is a sinking of air from above also. From all directions, the air will be sinking here. From all different directions, like a sinkhole, the air will be drowning there. They will hit the ground and the air will diverge in all directions. That is the case of an anticyclone. Whereas in the case of a cyclone, you will basically observe that around the low pressure, air gets attracted from all sides, from all directions, eventually rises up and diverges upon reaching the top. Now, out of anticyclone and a cyclonic condition, again listen to this carefully. Out of anticyclonic and cyclonic condition, where will you experience clear sky, lack of cloud formation, and dry weather? Out of anticyclonic or cyclonic, where will you observe clear sky, lack of cloud formation, and dry weather? Very good. It is going to be anticyclones. Why? Because in the case of anticyclone, the air is sinking down. When the air is sinking down, you will observe, this is the case of an anticyclone, you can observe a kind of a lack of cloud formation, and this is the top view above the sky, above the clouds. So you can observe here, there is a large gaping hole where the air is sinking down. Because when you have a sinking air column, that will never lead to or never cause any kind of a cloud formation. Right? That will never end up causing any kind of cloud formation whatsoever. So that is the case of an anticyclone. And in the case of a cyclone, because you have rising air, observe, this is from the International Space Station, this particular image. You can observe a wide band of this cloud formation. Multiple different bands you will observe, all in a spiral manner. Right? Because you have the rising air will lead to cyclonic formation. But the air circulation around this low pressure, when we talk about the cyclone, we are talking about extreme low pressure. Extreme low pressure. Now, the air circulation around this extreme low pressure will differ in direction in the northern and the southern hemisphere because of the Coriolis force. So, direction of circulation of air differs in northern and southern hemisphere. due to Coriolis force. What do we mean by this? So let's suppose I'm talking about, let's suppose, northern hemisphere first. Now, in the region of northern hemisphere, if I have a low pressure center here, now this will attract winds from all directions. This will attract winds from here also. This will attract winds from here also, and here also. Winds will be attracted from all direction. In the northern hemisphere, the winds will bend to the right. So here the winds will bend to the right. So if you are an individual who has been asked to go stand in the center of that low pressure, let's suppose, and report back what is the direction of circulation around that low pressure. Will it be clockwise or will it be anti-clockwise around this low pressure? Think about it. So you will come back and basically report that around this low pressure, the wind is moving in a direction somewhat like this, which is what? Which is anti-clockwise. So you have anti-clockwise circulation. Now, what about the southern hemisphere? Let's take the case of southern hemisphere. In the southern hemisphere, around the low pressure, there will be bending to the left. So here, let's suppose the wind is coming from all different directions. The wind virtually will bend to the left. Bending to the left means what? It will bend like this. It will bend like this. Like this, it will bend. Can we imagine a bending like this? So again, if I task you to go stand in the middle of the low pressure, what is the kind of a movement that you will observe? Wind motion somewhat like this. What is that? That is a clockwise circulation, isn't it? That is going to be clockwise circulation. Right. So that is basically the case when around the region of low pressure, the circulation of the winds will be very different both in the northern as well as the southern hemisphere. Okay, in the northern hemisphere, it bends to the right, so anti-clockwise. Now, please don't end up rote learning it. I have seen many candidates who like to rote learn northern hemisphere anti-clockwise, southern hemisphere clockwise. When you rote learn like this, when you rectify like this, there are chances for negative marking to happen very easily. You might have a complex statement in the exam, in the prelims, which might end up confusing you from top to bottom. So in place of clockwise, you will write anti-clockwise and vice versa. So rather than that, what I would suggest to you is have this kind of a simple drawing to be done in a piece of paper in front of you. After the session or right now during the break, you can do that. Any piece of paper, you know the basics that low pressure will attract winds. Now, in the northern hemisphere, these winds will bend to the right. In the southern hemisphere, these winds will bend to the left. Right? So just like that, form that basic drawing around you, and thereby you will be able to understand whether it is anti-clockwise or clockwise circulation. Please don't try to learn many things. The lesser number of things that you have to memorize, easier it will be. Now, then we come to the case of an anticyclone. Anticyclones are regions of high pressure. Anticyclones, basically, they are the regions of high pressure. So from the region of high pressure, can we say that the winds will get emanated and move in all different direction? Can we say that from the region of high pressure, the winds will originate and they will be moving in outward direction? As the air is sinking, wind will move. Now, as the wind moves outwards on the surface from this region, because high pressure is always going to be a source of wind, low pressure is going to be the destination of the wind, high pressure is going to be the source of the wind, the generator of the wind system. So, around this high pressure, what will be the direction of movement? Let us understand. So, here again, when we talk about northern hemisphere, follow the same logic. Winds are emanating in all directions, let's suppose. Draw it in a piece of paper, my dear friends, if it is possible, on your own. Now, in the northern hemisphere, the winds will be bending to the right. They will be bending to the right. So, what is this circulation around this portion of high pressure? Can we say that the wind movement is somewhat like this around this region of high pressure moving outwards? This is a clockwise circulation. Very good. And in the case of the southern hemisphere, it will be just the opposite. So if you have the high pressure, around that high pressure, the winds will emanate, but they will be bending to their left. The winds will be bending to their left. So what is this circulation? This circulation is basically a kind of an anti-clockwise circulation, isn't it? So this is anti-clockwise. Okay, so the cyclones will have different circulation and anticyclones will have a different circulation. Still amongst us, many of us who like to learn, it is a kind of a reference pointer for you. Basically, when you have a cyclone, you have a low pressure center in the northern hemisphere anti-clockwise, in the southern hemisphere clockwise. In the case of an anticyclone, you have high pressure at the center. In the northern hemisphere, it will be clockwise. In the southern hemisphere, it will be anti-clockwise. Can we say, Prem Kumar, can we say in cyclone winds converge from all directions, whereas in anticyclone it diverges in all directions? Yes, obviously, yes. Then Sushmit, my dear friend, kindly change your name from test. So, why will wind coming parallel to equator bend? Because in being parallel, they should not. Which wind are we talking about, Sushmit? The wind coming parallel to equator. Which particular wind are we talking about? The cyclonic winds. Okay. So think about it, that this low pressure center, just imagine that you have the winds coming from slanting direction. Let's suppose we don't consider parallel. From slanting direction, will they bend? So will they have a circulation? Ideally, you don't have this kind of a wind movement. Ideally, the wind movement is slightly different from a particular direction. More winds are fed and they keep on having that circular rise around the cyclone. Okay. So it is not always the case that you will have parallel winds which will start bending. So imagine, if I hope you are able to fathom that. So let's suppose this is the low pressure. Now here, ideally what happens, let me tell you, there will be wind coming from a particular direction. There will be winds coming from another direction. Both of them, they will start getting attracted to that low pressure and they will start rising up in a helical manner. So that rise in a circular manner that you see, that will be clockwise or anti-clockwise. Okay, this particular image that I have drawn, this is a very simplistic depiction of it, just to indicate that what is the circulation. But I hope you are able to fathom that or understand that particular thing. Dikshit, can there be rain in there is always very heavy amount of rain in the case of a cyclone. Are cyclones in both the hemispheres same powerful, or cyclones that are formed in northern hemisphere are more prominent, and what will come to it? When it comes to tropical cyclones, it is basically a different factor altogether, where it depends upon how much heating has happened. Temperate cyclones are not that common in the southern hemisphere wherever they are created, because in the southern hemisphere you have a uniformity of water body, but in certain areas where they are created, they are comparatively not that strong as compared to northern hemisphere. And in my village, sudden rise of air occurs. Okay. So, Bhima, are you talking about that near the open field where you see suddenly the rise of air with lot of dust and sand particles rising up in a circular manner? Is that what you're talking about? That is not known as a cyclone. Those are what are known by the name of dust devils. These are dust devils. Basically, you will observe this in open surfaces where you have some amount of soil, open soil, loose soil, which is there. That when it gets heated up, then there you have a almost very small remote low pressure, substantial thermal low pressure created. So the winds, they come to converge there, and that is when you have that spiral rise. Okay, right? I don't understand the right and left side bending. In general, about the right bending or left bending of Coriolis force, or in this case, Garima? How anticyclone affects in real world? When we talk about anticyclones, they create dry conditions on the ground surface, a substantial lack of rainfall, and they can cause rainfall somewhere else. For example, let's suppose here you have land, here you have sea, here you have an anticyclone. So this will influence the wind movement. And the wind which will be generated because of this will carry lot of moisture and will hit the land as an onshore wind, can cause rainfall. Otherwise, anticyclonic conditions are generally associated with dry weather. Okay. Coriolis case, if you are not comfortable with that, Garima, just look at the uh, recordings of module 7. We have discussed this in significant detail. Or you can do one thing, we have put an animated video about it also on YouTube. So on the channel now, please don't ask for the link. Please don't be that kind of an individual. Give me the paste the link here. I will just click and visit. Kindly visit that YouTube page of ours where you have the entire animation around Coriolis force also, or in pre-recorded lectures also you have a case about or a lecture about Coriolis force. There you will understand. And Prem Kumar, are cirrus cloud symbols of cyclone nearby? Not always. Whenever there is a cyclone, there will sometimes be occurrence of cirrus clouds because the formation or condensation happens at various different heights, even up till the top level. So there will be cirrus clouds, but it is not to say wherever there is cirrus cloud, there is a cyclone which is going to come. Okay, Vinod, how does tornado come on earth? So tornado is again basically the mixing of warm and cold air around the centers of low pressure. Basically these tornadoes, that is where you have the different vertical movement of, or at a different vertical level you have cold and warm air which mixes. The warm air tends to rise up, and around that central low pressure, as the cold and warm air masses mix, there is a rise of that warm air, but that rise happens in a spiral manner that, along with the cumulonimbus cloud, forms that kind of a suction power near the ground surface. That is what causes tornadoes. Not experienced in India, experienced mostly in North America. Vikram, sir, of cyclone occurrence is because of intense low pressure. Why does it occur in the month of December? Because of low pressure. We'll come to it. When we talk about Indian geography, the movement of or if possible, maybe tomorrow we can enter the portion of Indian monsoon. And there, when we talk about the movement of ITCZ, I'll let you know about the cyclone seasons also. Ankush, are Kal Baisakhi storms in Bengal are also cyclones or normal advectional storms? These are normal convectional storms. And Hindi meaning of anticyclone is something that I won't be able to tell you, my dear friend. So basically, anybody, if they're going to help me, then that is a different matter. But I won't be able to give you the Hindi meaning of it. Just understand, anticyclone is a region of extreme high pressure in an isolated area where you will have the air which hits the ground surface, okay, and then moves outwards. Prati Chakravat. Okay. Prati Chakravat. Chakravat is a cyclone. Prati Chakravat is the opposite of it. Or I have few of the more names which can come. Now here, by the way, are we not aware that tomorrow we have an extra session? I have already announced it a couple of times yesterday and day before yesterday. Tomorrow we'll have an extra session in the morning from 7:30 in the morning. We will try to continue till 11:30. We will give multiple breaks in between. So that is going to be the extra session for tomorrow, because you had one of the sessions which were cancelled because of my own personal health reasons. So that is where we are going to compensate it with an extra class tomorrow. This Sunday, we are not going to have a class. We will take a look into the possibilities maybe on the next Saturday, Sunday again. Okay? Right? Is that understood? Okay. Now, then we start studying these cyclones now. First of all, we will study the temperate cyclone. Then we will study the case of a tropical cyclone. Now, temperate cyclone. Clearly, the name in itself tells you it occurs in the temperate areas of the planet. It tends to occur in the temperate regions of the planet. So here, when we talk about the temperate cyclones, basically, region where they occur. Mid-latitude areas. From around 40° north to up till around 60-65° north, you will have these occurrence of cyclones. Why? The reason, because of dynamic low pressure created. Why will dynamic low pressure be created? Formation and distortion of a front. So, and listen to this carefully, for the temperate cyclone to develop and mature, there is a requirement of a frontal formation. Always there will be a requirement of a frontal formation. Without frontal formation, you will never be able to observe a temperate cyclone. But does not mean that every front will lead to formation into a temperate cyclone. Every front does not develop into a cyclone. Some of the fronts will develop. But for the formation of a cyclone, a front is required here. So, in this case, every front does not develop into a cyclone. Okay? But for formation of temperate cyclones, a front is a must. Okay. Now, here, so can we come to a conclusion that frontogenesis is required for the cyclonic formation? Now, from that, apply your logic and let me know in which season will this cyclonic formation be more prominent? In winter or in summer? When is it that this cyclonic formation will be more frequent and more prominent? Very good. Okay. Why summer and why winter? Why summer? All those of you who have given the answer summer, why is it so? Because of ITCZ, because of monsoon, because it will create low pressure area. Low pressure is created in summer. Okay. Because of in summer low pressure is created. Okay. Let me catch upon that logic, because quite a substantial number of you have given the same answer. So when we talk about the summer season, let's suppose this is your 0 degree, this is your 90-degree north. In the summer season, first of all, will you experience different pressure at different areas, or will the entire region experience a low pressure during summer? What do you think will be the case? Okay. Entire area. Okay. Do we remember something that we discussed, which basically sounded like tricellular model of atmospheric circulation? Do we remember that? Do we remember the tricellular model of circulation, where we discussed that at ITCZ there will be low pressure, at the region of subtropical high there will be high pressure, then at the region of subpolar low there will be low pressure, and then at the region of the poles there will be high pressure. Did we discuss a condition where the entire hemisphere will have a low pressure? Can that ever happen? That an entire hemisphere has got only low pressure? It will never happen, right? And when we are talking about mid latitudes, around 40 degree, around roughly 45 degree, 40 degree to maybe 60 degree, will you ever have the ITCZ crossing over to 45 degree north? Can you fathom a scenario where ITCZ crosses over to 45 degree? Absolutely not. Absolutely not. Under no condition will the ITCZ reach around 50 degrees unless and until the axis of the Earth suddenly bends. It will never reach. Also, low pressure can never be created over the entire hemisphere. The Earth is a spherical object. Different areas receive different amount of solar insolation. Some area might get more heated up, other area will be comparatively cooler, right? Comparatively cooler. So comparatively cooler means a comparative high pressure can always be created, will always be created. And moreover, in case you did not notice, here, what did we observe? What is the reason for the formation of a temperate cyclone? Is it associated with thermal conditions at all? No. It is associated with dynamic conditions, the dynamic movement of the winds. Winds will converge, there will be rise, and that is going to create that low pressure. So, in that case, will you have the impact of thermal conditions on the ground that much? No. So, that is where here basically they are more prominent as of now. I seriously would advise all of you, keep the portion of tropical cyclone Michong, what happens in Bay of Bengal, Arabian Sea, keep it out of your mind. Focus on this temperate cyclone, because again, just like the case of the occluded front, this is going to give you sleepless nights eventually. If you are unable to understand that, this will create a lot of issues, because it is not explained. Cyclones is one of those portions which books they do not do proper justice to. So that is why pay attention only to this portion. Apply all the mental energy that you have only to this portion. Okay. So mostly formed during winter. Why mostly formed during winter? We have discussed yesterday also, as frontogenesis is much more common in winter, because of temperature difference between the polar area and the tropical regions. Frontogenesis is much more common, much more prominent. Now here, this low pressure, this low pressure is formed over the region of the front. Now fronts, they are not small areas, because the air masses, when they can extend for hundreds and thousand kilometers, fronts can also extend for tens and hundreds of kilometers. So around that low pressure, as the air will rise up, there will again be a large area of that cyclonic coverage. So overall, when you take a look at the entire cloud formation, everything associated with this cyclone, it can have a diameter of around 750 to 1000 kilometers easy, right? It will be formed over a very large area. So formation happens over very large area. Formation occurs over large area. If it's dynamic low, then why we consider the high temperature gap of winter? Okay. Srilata, what is it that you have not understood up till now? I want you to pinpoint. I'm just talking about the features of the cyclone. I will discuss the cyclones in detail. So, Ankush, my dear friend, understand this. Why does frontogenesis occur? We have already covered this. It is just that you have some preconceived notion and you are unable to remove that from your mind. So basically, why does frontogenesis occur? Air masses of different properties meet. Greater the difference in temperature of air masses, difference of temperature between air masses, fronts will be more prominent and more developed? When is it that you have a greater difference in temperature of air masses? That is going to be experienced during winter. Greater difference. Now, how is it dynamic low pressure created? When you have a front, you have a cold air, you have the warm air comes, it rises up on the ground surface. Can we say that there is a rising air column? Can that rising air column lead to low pressure? Is that understood? Srilata, is that understood? What is the doubt? Please be specific in the doubt. I can help in that case. Otherwise, I won't be repeating the entire thing. Is that understood now? Okay. I'll move forward then. So basically, when we talk about these temperate cyclones, these are created in the mid-latitude regions. Listen to this very carefully again, guys. Please don't get so very predetermined in your point of view that my argument is correct. It is okay to be confident, but you have to be open to possibilities. That is what leads to learning. Otherwise, learning won't happen. So try to open up your mind. That is why I told you, forget everything about tropical cyclone, Michong, Bay of Bengal, Arabian Sea, because tropical cyclone does influence us Indians. So we Indians, whenever we think about cyclone, we only can think about the tropical cyclones. That is why temperate cyclones is something which is difficult to fathom, difficult to imagine for us. Temperate cyclones are created in the mid-latitude whenever you have a distortion of the front. Now, front formation is associated with the air masses, cold air mass, warm air mass. That is what leads to the front formation and the distortion of the front as well. Now, these fronts, eventually, when they get distorted, these fronts, they can sometimes create that low pressure, which can lead to the formation of a cyclone. How, why, where, etc. We'll come to it. But then this low pressure is created over a larger area. Mostly during winter is when they are very prominent. That is where even the cyclone formation will influence a very large area. Now let's suppose in a region you have this cyclonic formation in the temperate area. Now in the temperate region, this entire formation in itself moves from west to east. Cyclonic formation moves from west to east under the influence of westerlies. Of westerlies. Okay? Under the influence of westerlies. So here, that is the property. So a temperate cyclone is also what is referred to as a mid-latitude depression. Depression, trough, etc. They represent that low pressure condition. So mid-latitude depression, extratropical cyclone, a frontal depression because it occurs across a front, or a wave cyclone. Why a wave? Because as we saw earlier, that the meeting of the warm and the cold air mass, that represents a kind of a wave-like format. If you basically recall that earlier discussion that we had, remember, the meeting of the warm and the cold air mass, that never follows a straight line. It will be kind of a wavy pattern, which will be indicated here. Right. So that is what is referred to as a kind of a wave cyclone. Now, these temperate cyclones are active above mid-latitudinal regions between 35 degree to 65-degree latitudes in both the hemispheres. Okay, so in between the 35-degree to 65-degree latitude in both the hemispheres. Now, direction of movement is from west to east under the influence of westerlies and is more pronounced during the winter season when there is a greater difference of temperature. It is along these latitudes that polar and tropical air masses meet and they form fronts. Sometimes, when the front distorts, that is when you can have the development of a cyclone. Just the formation of a front does not mean that a cyclone will be created. Sometimes these fronts they get distorted and lead to the formation of a cyclone. Now here, let us consider the various different stages of cyclone. Okay, how is it that this cyclone develops? And listen to the next few minutes very carefully. Now, first of all, you will have a condition where the warm and the cold air mass they come head to head. So basically, you will have the cold air and you will also have, let's suppose, the warm air. So initially what you will observe is the formation of a stationary front. Initially, a stationary front will be observed. Now from this level or from this stage of stationary front, it can eventually sometimes even lead to frontolysis. It might happen that none of the air masses, neither the cold or the warm air mass, it can happen that none of them gain enough energy or enough power to venture into others' territory. That can happen. So then frontolysis will occur after 2 to 3 weeks. But let's suppose that warm air tries to enter into the region of cold air and cold air enters into the region of warm air. So basically, if no movement of air mass, frontolysis will occur. Okay. Now, if there is a movement, if air masses move, distortion of front will happen. That is, warm air will try to enter into the region of cold air, and cold air will then try to enter into the region of warm air. Now, after this comes the second stage. That is the beginning of the cyclonic circulation, the beginning of young adult. So, what happens here? As you can see, cold air tries to push in, warm air tries to push in. Now, always remember, regardless of whether the cold air pushes forward or the warm air pushes forward, on the ground surface, it is the cold air which will persist. The warm air will start to rise up. Okay? Whether it is a cold front or a warm front, the warm air tends to rise up. So here, you will have a distortion of a front. Let's suppose in this region, you have the cold air which starts coming in. Let's suppose. In this area, let's suppose you have the cold air. And let's suppose in this area, you have the warm air. This is when the trigger for the cyclone can happen. Because now it will lead to what? It will lead to simultaneous development of two fronts. Cold front on one side, warm front on the other side, isn't it? Let's suppose this is the warm air. So, will lead to simultaneous front formation will lead to a kind of a simultaneous front formation. Both cold and warm fronts will be formed simultaneously, isn't it? Now here, if you take a look at it, cold front has got different property, warm front has got different property, but both of them are associated with the rise of air. Both the fronts are associated with the rise of air. So rise of air is in a way going to link to what? A low pressure. So here, basically, rise of air happens. Air happens. And when you have the rise of air, what will that lead to? Low pressure development. Over a large area. Now this triggers a kind of a feedback loop. What feedback loop? That is the mature stage of the cyclone. So what is that feedback loop? So understand this. Rise of air will happen. Creation of low pressure. Low pressure means what? More winds are attracted. More winds are attracted. More winds getting attracted means what? More winds will converge. When more winds will converge means what? Further rise of air. Isn't it? So as a consequence of this, what will be the outcome? Low pressure will get intensified. And during this entire process, where the low pressure is getting intensified, during this entire process where the low pressure is getting intensified, what do you observe? You will basically observe as this low pressure intensifies itself, thereby more rise of winds, more attraction of winds, more rainfall. But rainfall cost will be different. In the region of the cyclone, it is not as if only one kind of cloud formation, one kind of a rainfall. Because we do know that you have a simultaneous formation of a cold front. This will also be associated with very strong wind movement. So here, you have the simultaneous occurrence of a warm front and along with that, a cold front as well. Now, at this region of the cold front, the weather associated will be what? So here, you will observe cumulonimbus clouds. This is the cold front. Cumulonimbus clouds. Heavy and violent rain with thunder and lightning. Rain with thunder and lightning. isn't it? Whereas on the other side, in the case of a warm front, you will have nimbostratus. So here you will have nimbostratus. Means moderate amount of rains. Rains and prolonged rainfall. Moderate and prolonged rainfall, isn't it? So around this entire area of low pressure, here also winds will rise. Here also winds will rise. So there is that large area of low pressure. So that is why whenever these temperate cyclones are at their mature stage, you will observe basically a very large aerial coverage in terms of the cloud formation also, because the air is rising up. Eventually the air is converging around that low pressure, rising up in a kind of a spiral or helical manner in many of the cases. In many of the cases, in some small areas of cold front or warm front, there also you will have a rise. Regardless of whether it is the cold front which is moving ahead or warm front which is progressing, slowly and steadily on the ground, you will have the predominance of only the cold air. Because even in the case of a warm front or a cold front, on the ground surface, it is the cold air which tends to remain. Okay, so here basically observe here on the ground around this region of low pressure, on the ground, as both fronts progress, on the ground, cold air dominates. Is this portion understood? Is this portion understood? Why cumulonimbus in cold front and nimbostratus in warm? We have already discussed that, isn't it, Krishika? We have discussed the cold front and the warm front, where you had the vertical rise of air and a gradual rise of air. So that is what is responsible. Kindly take a look at the recordings in case you have missed it out. Today itself we have discussed. In both fronts, wind speed and nature will be the same? No. Generally, cold fronts are associated with much more violent winds. Is this particular, till this particular point, is this understood? Whenever the cyclone occurs, the reason for continuous rain is due to the combination of nimbostratus and cumulonimbus. That is correct. Does the subpolar low pressure have any role? So it is in this region of subpolar low pressure, Vikram, where you will have this entire creation or existence. Now, as a result of this, as on the ground, the cold air will be dominant, because in both the warm front and the cold front, what have we seen? On the ground, it is the cold air which remains, warm air rises up. So here, the front begins to close. That is beginning of occlusion. Occlusion is when it starts to close. That is when the cyclone is about to get dissipated. And eventual last stage is the late occlusion or dissipation of the cyclone, where observe that the front has basically closed down. The front has basically closed down from all various different sides. So that is where you will observe that this front has closed down. Now, what will happen? Eventually, in this area where the entire formation was happening, on the ground, now you only have cold air, right? No further deformation of the front. So we can say that the cyclone is dissipated or frontolysis will happen. So eventually cyclone gets dissipated due to frontolysis. Isn't it? Because here the front has closed down. Because on the ground here you have cold air on all sides. So why will there be a front anymore? So now you can have a stationary front maybe established here, or a complete frontolysis can also occur. Okay. Lakshmi, you have the same question for a long time. If a person stands in the center of the cyclone, then what happens? What do you think will happen? Nothing will happen. In the case of a tropical cyclone, you will experience sunlight. In the case of a temperate cyclone, you will experience rainfall. And Meghna, whenever the cyclone occurs, the reason for continuous rains is due to the combination. Yes, we have answered that. So they come close to each other. So how cold air dominates? Take a look at the earlier portions that we have discussed, Megha. We have discussed that whether it is a cold front or a warm front, it is always the warm air, mostly some amount of cold air which gets lifted up, but cold air remains on the ground surface. And Likhani, fifth stage or the stage of occlusion is when the front has finally, so the entire deformation of the front which was happening, that front has closed down. So it was across this entire front where that rainfall was happening. Now that front has closed down. So the entire low pressure system will come to an end. Okay. Distortion of the front leads to the temperate cyclone. How occlusion leads to closing of cyclone. Occlusion is what? Occlusion is when the front eventually disappears. That is what occlusion is. If I take you back to this particular area, what is occlusion? Observe here, this is where the front was there. Now the front got deformed. Eventually, what will happen? The front has closed down. Observe this one, for example. Observe here, the front gets deformed, significantly deformed. There is a kind of low pressure center eventually, but then eventually that also dissipates, right? So that is the dissipation or the end of the cyclone. Okay. Here, can we observe negative lapse rate in this region? Yes. Wherever there is a front, you will. Cyclone is not a frontolysis. No, cyclone is a low pressure center, Rajkumar, around which you have a circulation of wind. Torrential rainfall is huge or excessive amount of rainfall continued for a long period of time. Where is the eye of the cyclone in that front collision portion? In the case of a temperate cyclone, it is not always that you will find the formation of an eye. Temperate cyclone can sometimes have an eye, sometimes cannot have an eye also, right? So here it is not necessary that not all the temperate cyclones develop an eye. If you have that distinct low pressure center around which the air is rising, you will have an eye. But if across the entirety of the front there is that rise, then you won't have an eye. So that is why tropical cyclones always have an eye. Temperate cyclones will or will not have an eye. Okay. Shruti, this particular cyclone does no, Lekni, it is absolutely not a ridiculous request. Thank you for bringing that to light. We'll take care of it in going ahead. So, Shruti, how much time does the cyclonic process exist? It exists for a period of around 2 to 3 weeks. It does exist for a period of around 2 to 3 weeks. Does front form at subpolar low pressure? Yes. Sushmit, that is correct. Okay. So with that, digest this for some time. We take a break. We take a break for 15 minutes and then we basically move ahead. Okay. So slide of theory of temperate cyclone. Okay. This portion or this portion? Let's talk about this portion. So let's take a break of 15 minutes and let's be back in 15 minutes. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. Now, after this, in the case of temperate cyclones, we sometimes experience a kind of sudden acceleration of that cyclonic disturbance, where the cyclone gets intensified in a very short time duration. Basically, whenever you have a creation of a low pressure, the meteorologists, the climatologists, they are able to predict that this low pressure will have this strong wind movement, this will be the velocity of the wind, etc. But sometimes, due to the rise of air and sudden unexpected movement of air, sometimes the low pressure intensifies very rapidly, where the low pressure drops by more than 24 millibar within a duration of 24 hours, within a duration of 1 day. And then the cyclone gets and becomes much more intense, much stronger than before. And that is what is known as a bomb cyclone. So, bomb cyclone is basically here, just like the name bomb, bomb is used whenever there is an explosion. So, whenever the cyclone intensifies very significantly and over a very short time duration, it becomes very, very strong. That is what is known as a bomb cyclone. So it is a powerful, rapidly intensifying storm associated with a sudden and significant drop in atmospheric pressure. It involves a drop of 24 millibar or more of a pressure within the time duration of 24 hours. Now, this sudden intensification of low pressure kicks in a very rapid development of a cyclone, and that is what is known as the bombogenesis or explosive cyclogenesis. It is basically when low pressure intensifies suddenly. The entire cyclonic disturbance gets much stronger and gets a very rapid and powerful wind movement. So that sudden intensification leads to formation of a bomb cyclone. Okay, leads to formation of a bomb cyclone. Okay, so this formation is known as bombogenesis or explosive cyclogenesis. mostly is observed in the case of, majorly it is observed in the case of temperate cyclones. Sometimes this phenomena will also be observed in the case of a tropical cyclone. Okay. Now that brings us to the topic of a tropical cyclone. Now, when we talk about the tropical cyclone, this is the kind of a cyclonic disturbance which frequently impacts the Indian subcontinent. Now, this tropical cyclone, even though it is much smaller a formation, if you observe the cloud formation here, if you observe the cloud formation here, this disturbance has occurred over a much smaller area if you compare it with the temperate cyclone. Temperate cyclone, the entire formation developed across the entire region where there was a front, right? So that is where you had the development of a temperate cyclone. But in the case of a tropical cyclone, it is restricted over a very small area and it is much stronger. The wind movement is much stronger, primarily because this cyclone is created due to intense low pressure or a thermal low pressure created due to a thermal low pressure. That is created due to a thermal low pressure. So this thermal low pressure will attract very strong winds. Attract very strong winds. Now, when we talk about a tropical cyclone, it is observed in the tropical waters is where it develops. Tropical cyclone will always develop only above a water body. Why? We will talk about that. But it only and always develops over a water body, and thereby it then progresses or translates into the nearby regions. So, when we talk about a tropical cyclone, that particular tropical cyclone will be developed over the tropical waters across the world. They are known by different names. For example, the tropical cyclone developed over the region of North Australia. That is known by the name of Willy Willies. The tropical cyclone which develops over the region of Atlantic, they are known as by the name of hurricanes. The tropical cyclones which develop over the region of Western Pacific, around South China Sea and the eastern portion of Asia, that is known by the name of typhoons, extending all the way up till Japan sometimes. So that is why these storms are named differently. In the case of Bay of Bengal and Arabian Sea, they are named as cyclones. They are named differently, but they are together named as cyclones. Now here, not every low pressure will develop into a kind of a cyclone. You do need certain prerequisite conditions to be fulfilled if you will observe the formation or development of a cyclone. You need certain prerequisite conditions to be fulfilled. We'll come to that. So, tropical cyclones are violent storms that originate over oceans in tropical areas. They can originate, do not form over land areas. Because of the process of formation, they will never be created over land areas. They will always be created over oceans. Why? We'll come to it. They are known as cyclones in the Indian Ocean, hurricanes in the Atlantic, typhoons in the Western Pacific and South China Sea, and by the name of Willy Willies in the region of Western Australia. So they are named by different nomenclature. Now, there are some prerequisite conditions which are required to be fulfilled for the formation. But before that, let us talk about the process of formation. So, this is the naming of the cyclones in different areas. Okay. In northern Indian Ocean, they are basically known by the name cyclones itself. Now, here, first of all, let us talk about the formation. Then we will take a look at the essential conditions. It will make much more sense. It will be easier to understand also. So let us talk about the formation. Now, as we said, that it will be formed over the water body only. So when you have a large water body, gaining a temperature of 27 degrees Celsius or more, tropical waters on an average indicate a temperature of around 24 degrees Celsius. So when you have a large water body indicating a temperature of 27 degrees Celsius or more, that is when you have a substantial low pressure which gets created. Okay. So let's suppose in this entire area, you have a significant low pressure center which gets created. Now, around this low pressure, what will happen? Winds will get attracted from all sides. Winds will travel across the water body and will get attracted here. Now, what will be the moisture content in these winds? Will these winds be moist or will these winds be dry? What do you think? Moisture content will be very high. These winds will be very moist. So when the winds are very moist, very humid, so in that case, can we say that condensation will happen much more easily? Condensation can happen at a quicker pace. Can we think about it? Right? Now, these moist winds, when they come into the region of this low pressure, they will also get heated up because of the hotter surface. And then they will initiate the rising up. But they will not rise up straightforward. Due to the Coriolis force, they will be rising up in a kind of a helical manner. In a kind of a spiral manner. Now, and then eventually when they rise up, then they might diverge. But here is where you have to understand this rise. So winds are rising in a kind of a circular pattern. A kind of a circular pattern is how that the winds are rising up. So as the winds are rising up in a circular pattern, condensation will happen. But can we say that condensation will happen in a circular pattern? Can we come to the conclusion that as the winds are rising, there will be condensation happening all around that central circle? Are we comfortable with that? That around that central circle, you will have that condensation happening all around the sides? Yes? Any doubt in that? Okay. How? So, are we comfortable with the fact that the winds will rise in a circular manner? Are we comfortable with that fact that the winds will be rising up in a circular manner? because of Coriolis force, the winds they are getting attracted, they will rise. There will be a circulation in clockwise and anti-clockwise direction in various hemispheres, right? In the northern hemisphere, you will have anti-clockwise circulation. In the southern hemisphere, clockwise circulation. Now, this winds basically will rise up. As they will rise up not straight. If they would have risen up straight, condensation would have happened up one on top of each other, but they are rising in a kind of a circle. So the condensation will happen all around that side of the circle. Is that understood now? Okay. Now, so here, condensation will start happening on the sides. Condensation will start happening on the sides. Let's suppose condensation has happened like this. Now, every time that condensation happens, there will be latent heat of condensation which will be released. I hope we are aware about the term latent heat. Whenever there is a change of state from, let's suppose, solid to liquid or liquid to solid, liquid to gas or gas to liquid, there is that heat which is consumed or given out whenever there is that change of state. Are we aware about the term, that latent heat? Yes, that there is no temperature change, but there's a heat released or heat consumed, right? So every time that condensation happens, latent heat of condensation is going to be released. During condensation, latent heat of condensation is released. Okay. Now, here, as the air is rising in a kind of a circular spiral and condensation is happening all around that circle, can we think about a scenario where all that latent heat will be released around the central portion? That is where the latent heat will be released, isn't it? So as the air is rising up in a circular fashion, heat will be released during condensation, and wherever that condensation is happening, there heat will be released. So where is the condensation happening? All around that circle. So latent heat will be released where? Into the circular portion. So let's suppose this is where the latent heat is getting released. This is the release of latent heat. Of condensation. This is the release of the latent heat of condensation. Okay. Now notice on one other fact. The air is rising up in a spiral manner. That will impact the air in this circular portion also. How? So, for this, recall a kind of a childhood mischief that you would have done, or a kind of an experimentation that you would have done. Well, let's suppose you have had a bucket of water, and if ever you have tried to rotate that water with your forearms, where basically you have a bucket full of water and you have tried to rotate that water with the forearms. Have you ever tried to do so? Or have you ever seen someone doing so? Yes? Now, in that case, on the sides, you would have observed that water spills out from the bucket. The water would spill out from the bucket, isn't it? So the water is rising in a circular manner and spilling out from the bucket. What happens to the central portion? Does the water remain at the same level in the central portion? Does the water level rise up, or does the water level fall down? Whenever you rotate that water with the help of your forearm in the bucket, does the water level rise up in the center? Does it remain the same, or does it fall down? What happens? It falls down significantly. Whenever you would have done this, if you have not done this till now in your life, first of all, I don't believe that you would not have done this in your life ever. If you have not done this in your life till now, try it out. Try to rotate the water in the bucket with your forearms. There is a kind of an outward spiral movement, and in the central portion there is a kind of a suction created. So that suction is here. Air also indicates a kind of a similar fluid movement. So as the air is rising up along the sides, in the central portion, what will happen? In the central portion, there will be a suction, right? So that basically would mean what? It would mean that air from this area, from this region, is sucked in around the central portion. You have sinking air column because of that suction created due to the rising spiral. So you have a sinking air column. Now this air, as it is forced down because of that movement, as this air is forced down, can we expect a kind of an adiabatic heating, compression, and this will accumulate all the latent heat as well along the way? So this air will get adiabatically heated as it will fall down, isn't it? So what will it lead to? Basically, it has accumulated the latent heat also, and there is adiabatic compression of the sinking air. Compression. So this air warms up. Now, around the region of low pressure, as that warm air will fall, what will it lead to? It will lead to intensification of low pressure. The low pressure gets intensified. As it gets intensified, what will happen? This low pressure becomes much more stronger. It will attract more winds. More moist winds will be attracted. More moist winds will be attracted. More of them will rise up along the spiral. As more of these winds will rise up along the spiral, what will happen? As the winds, they start rising up along the spiral, there will be cooling and condensation along the way, isn't it? And there will be condensation again along the side of the spiral. Will there be condensation in this central portion? Will there be any condensation in the central portion? Yes or no? Very good. There won't be any condensation in the central portion because of two factors. First of all, it is in the central portion where you have that sinking air. Sinking air is never associated with condensation or cloud formation. For that, you need rising air, right? So that the air cools down and condenses. And in the central portion, you have all the latent heat which is accumulated. So it is warmer. The central portion is always going to be much warmer as compared to the sides, right? So no cloud formation in the central portion. The central portion will be clear. But as more air starts rising up, they will condense around that spiral. So what will happen to the existing clouds? The existing clouds will be pushed slightly aside. So that is when you have the existing clouds which will be pushed aside slightly, so we can say that the clouds will grow from inside out. They will be pushing the existing clouds aside. So these clouds will become much more significantly intense. The existing clouds have been pushed aside and the newer cloud formations have been observed. Existing clouds have been pushed aside. And newer cloud formations would be observed, right? Now, that is how overall the expansion happens. Now, this entire process of formation actually is self-feeding. It feeds itself. How? So when we talk about this entire process of formation, understand that condensation will lead to release of latent heat, release of latent heat, then low pressure gets intensified, okay? Low pressure gets intensified means what? More winds will be attracted. Attracted. Winds will rise up. Rise up. Further condensation will happen. And like this, the low pressure keeps on getting intensified. More heat is generated on its own. Without any external intervention, heat continues to get generated and the low pressure continues to get intensified. But for this entire process to take place, you need quick condensation. You need moist air. Because if you have dry air coming into the mix, that dry air will not have that much condensation which will occur. And when you don't have that much condensation, that much amount of latent heat won't be released. And thereby, the low pressure will not get intensified. So that is why this particular kind of cyclone, tropical cyclone, will only form over water bodies where you have that continuous supply of moist air. More moist air keeps on coming in, more amount of that heat gets generated, low pressure keeps on getting intensified, the winds keep on getting stronger and stronger. That is why longer the time that the tropical cyclone spends over the water body, stronger and more powerful it becomes. The moment it hits the land, that is when it starts weakening, it starts dissipating. But we'll come to that. Before that, this central portion, low pressure is not the land area. Low pressure is the water body. Water body which has gotten heated up beyond 27, 28 degrees Celsius. In certain cases, water bodies, they get heated up to a range of 32, 33 degrees Celsius. That also happens. Okay. Now here, this central portion, this is known as eye of the cyclone. Eye of cyclone. Clear sky, no clouds. No clouds. Vibhu, sinking air column won't affect the low pressure. Here you have the thermal low pressure which is created, and that sinking air, it is not that powerful which will create a dynamic high pressure in between. Having said that, this sinking air column is very important for the continuation of this cyclone because it continues to intensify the low pressure area. But it is not a very strong sink. If you can think about it in that way, it is not a very strong sink. It is a kind of a weak sink associated. Okay. Now, what will lead to the movement of cyclone? The permanent wind system. The permanent wind system, in the case of the temperate cyclones, we observed that it is the case of the temperate winds, or basically the westerlies, which would influence a west to east motion. Here, which wind system will impact the movement in the tropical regions? Which are the wind systems in existence? Are we aware? Trade winds. Very good. So these trade winds, basically, they will end up influencing the movement. And trade winds move in which direction? They move in east to west. That is why these cyclones will always move in a direction east to west. Okay. So here, that is the case of a cyclone formation. Now, because this cyclone is able to generate its own heat, that is why it is also what is known as a heat engine. Because it is able to generate its own heat. Now, the sides where the clouds are going to be very, very thick, this is what is known as an eye wall. Okay. Now, what happens when the cyclone makes a landfall? When the cyclone hits the land? What happens in that case when the cyclone moves over and hits the land? As the cyclone hits the land, first of all, these rain bands will cause heavy rainfall. There will be a very strong wind movement associated. As the winds from all directions come towards the center of the low pressure, there will be a very significant wind movement. So strong winds, heavy rains, that is something that you experience. But then the eye will come over to the land. Now, as soon as the eye comes over to the land, you have clear sky, lack of wind movement, calm conditions. Why? Because in the region of the eye, you have a sinking air, lack of cloud formation. So as soon as the eye comes over, you have clear skies. Many of the people think that it is the end of the cyclone, but it is not. The other end of the cyclone then hits. And again, it will have a very strong wind movement, very heavy rainfall. But once that low pressure center shifts over to the land, it will be attracting winds from the nearby land areas. Now, those winds would generally be comparatively drier, so that much condensation will not happen, right? That much condensation will not occur. So, low pressure will not get intensified. So, that is when, as soon as the tropical cyclone hits the land, it starts weakening because of that loss of moisture supply. and eventually it dies out. Okay, because a continued supply of moisture is required for the sustenance of this cyclone. That is why this cyclone weakens when it hits the land. Okay, right? Hurricanes are basically when you have a super strong cyclone, severe cyclone, which develops in the region of the Atlantic. Can't visualize latent heat. Okay, how many of us are not aware about what is latent heat? Are we aware about latent heat? Okay. Latent means something which is imbibed, which is hidden. So basically, you would have done this in your childhood days. If you would have kept the experiment that you would have done, basically, the experiment goes that let's suppose you take a jar of ice, you fill it with ice crystals. Let's suppose you fill it with ice crystals. Now, let's suppose there's a thermometer that you put in. Let's suppose, and you provide heat. Now, if you plot a graph for the temperature and the heat, ideally the amount of heat given should be reflective in temperature. So when it is complete ice, then as you heat it up, the temperature continues to rise till it reaches the melting point. After that, you continue to supply heat for some time, but the temperature doesn't indicate any increase. Why? Because that heat which you are supplying now, that is not indicated in temperature rise, but that heat is consumed to change that solid into liquid state. Because when you convert something from solid to liquid, you need the breaking of the bonds, the molecules, they are bound together, you need to break them. So for that, you need that heat, you need the energy. So heat is consumed without changing of state. Now, again, when it is completely, it has melted out. Again, when you provide that heat, it will continue to indicate a rise in temperature till it reaches the region of the boiling point. Again, after that, if you provide that heat, it will not indicate a rise in temperature, but that heat will be consumed to convert that liquid into gaseous state because more bonds need to be broken. And then in the gaseous state, again, there is that rise of temperature. So this particular heat, which does not indicate a rise in temperature, this is the heat which is consumed during melting, consumed during vaporization. This is latent of melting, heat of melting, and this is latent heat of vaporization. Of vaporization. Now, converse of it, when you cool down the gaseous particles, vapor, when you cool down the gaseous particles, heat will be released continuously, temperature will continue to drop, but some amount of that heat which will be released will not be indicated by the temperature change, but that heat will be released will be to reform from the gaseous bonds to the liquid bonds. The reformation of the bonds, they will release some heat, not indicative by the change of temperature. That reverse process is the latent heat of condensation. So gaseous to liquid or solid state, you will have latent heat of condensation released. Is that understood now? Of condensation is released without the change of temperature. Is that understood? Anjan and Twisha, both of you had issues. Is that understood? Okay. But this is something you would have studied in your elementary science classes, isn't it? Or is this not covered nowadays in the 7th, 8th standard science? Is it something which is covered or not covered nowadays? Anyways, I hope not covered. Somehow I don't believe that, but still, let's suppose it is not covered. So here, now I hope you have understood what is that latent heat. Now, after this, yes, even I am not ready to believe it, Ankush, but we move on. So, that is the case of the entire process of formation of the cyclone. Let me repeat this entire process. The water body, when it gets heated up, that water body attracts winds, moist winds from all directions because there is a substantial development of low pressure. This will attract winds from all different directions. As the winds get attracted from all different directions, all various directions, these winds will also get heated up and they will start rising. As they start to rise up, eventually what happens, there will be condensation. They will rise up in a spiral manner. Condensation will happen along the sides of the spiral. As this condensation happens, it releases latent heat into the central portion. So the central portion becomes hotter in comparison to the sides. The central portion becomes warmer. Now, thereby, this central portion, which becomes warmer or hotter, there the temperature increases. Meanwhile, as you have that rising spiral of air, it creates a vortex kind of a suction in the central part, in the eye. Now, that slight amount of air which starts to sink, it will accumulate that latent heat which has been released, and that air will further get heated up due to the adiabatic compression. It will hit the surface. Thereby, it will heat up the surface even more. And that will intensify the low pressure. Once the low pressure gets intensified, more winds will be attracted from all sides, and further winds will rise up. More condensation will happen across the sides. As more condensation will keep on happening across the sides, the clouds will keep on getting developed. And these clouds, they get pushed to the sides. Right? These existing clouds, they get pushed to the side. And you have development of these individual rain bands, thick cumulonimbus clouds. Now, eventually, this entire cyclonic formation moves due to the help of the permanent wind system. And as it moves due to the permanent wind system, that is where it will move from east to west. And as it moves from the region of east to west, thereby it will make contact with the land. As it makes contact with the land, that is where basically what will happen? It will bring rains, strong winds, heavy winds, along with rains. And that is when the land areas, these land areas will receive very heavy bouts of rainfall. Very significantly heavy bouts of rainfall will be received. And when that landfall happens completely, the low pressure region travels over to the land. That is when the supply of moist winds that gets cut off. and the development of cyclone no longer happens. And that is when the cyclone starts to dissipate. Okay? Now, sometimes what happens? Are we comfortable up till here? Are we comfortable up till here? Yes? Okay. Sometimes what is also observed is the fact that these cyclones, when they hit the land, let's suppose the land area had already received a lot of rainfall, or there is a prevalent existing low pressure in the land area, rather than weakening for a few moments or for some duration, the cyclone gets stronger. If let's suppose the land area has already received rainfall and there is moisture present in the ground and you already have a low pressure on the land area, this low pressure travels and hits it. Then sometimes, in certain cases, we have also witnessed the strengthening of the cyclones upon hitting the land, but that is a very rare case. Cyclone Tote, which last year basically hit the western coast of India around Gujarat, Maharashtra, that got strengthened because you already had a pre-existing low pressure and moisture in the region of Gujarat. So it strengthened in the region of Gujarat, causing devastation, causing destruction. But that is a very rare case. Mostly, as soon as the cyclone makes landfall, it weakens. Now let us take a look at the conditions which are required for the formation of this cyclone. Now it will make more sense. So for this, large sea surface with temperature higher than 27 degrees Celsius. This will create low pressure. It creates low pressure, and large sea surface becomes a source of moist, warm winds. Becomes a source of moist, warm winds. Then after that, presence of Coriolis force is a must. If you don't have a Coriolis force, then you will never be able to attain a circulation. You will have a rise and fall, but you will never be able to attain a kind of a circulation. So this is why the cyclones, tropical cyclones, will never be able to cross the equator, or tropical cyclones are not formed at the region of equator because there you don't have any Coriolis force. So that is why tropical cyclones are formed from around 5-8 degrees north to around 23-24 degrees north, and 5 to 8 degrees south to around 23-22 degrees south latitudes. It is never formed in the region of equator because then the circulation will never be attained. Hence, cyclones never cross equator or never formed at equator. Okay, that is why it is never formed at equator or never even crosses the region of equator. Now there should be a very small variation in vertical wind speed. What does this mean? This basically means that the wind speed, this is also what is known as wind shear. So what this means is that the wind speed near the surface and the wind speed higher up, there should not be much of a difference, right? So what this means is that speed of the wind, or difference between speed of the wind near the surface and higher up should be similar. or should be very less. Means difference is very less, means the speed should be similar. Why? Because let's suppose near the surface you have weaker winds and above you have very strong winds, very strong winds. Then whatever rising up will happen, it will be carried over by the wind. The entire cyclonic formation, the entire cloud formation, etc., won't be observed. So that is why the vertical difference or the vertical wind speed needs to be similar. At different vertical levels, the wind speed needs to be similar. Then a pre-existing weak low pressure area, wherever you have a pre-existing weak low pressure, that can intensify upon heating. That is why these cyclones, they germinate very frequently in the regions where the ITCZ lies over the water body. They get created very frequently. Hence, these cyclones get created very frequently where the ITCZ crosses over the water body. Okay? Wherever the ITCZ crosses over the water body, that is where these cyclones will be very prominent. Okay? Small variation in the vertical wind speed. That portion is not understood. Understand, this simply means, that is why I have written this up. Read this. What is this written? Speed of the wind near the surface should be similar to the speed of the wind higher up, so that that entire disturbance is allowed to form. Otherwise, what will happen? If you have a very strong wind movement in the upper atmosphere, even if, let's suppose, you have a cyclonic formation, here you have the rise of air. If you have a very strong wind movement here, will that allow the entire formation of a circular spiral cloud formation? Will that be allowed? The wind, will it allow the entire formation to happen? Absolutely not. That strong wind, upper wind, will carry this all away. So the ground surface low pressure or the water level low pressure will get disconnected from the disturbance above. So that is why if you have to see the complete cyclonic development, the upper air wind movement should be similar to the wind movement near the surface. Now, after this is the kind of the schematic diagram where you observe the rise of the wind, and as the wind rises up in a spiral, basically the condensation happens on the sides and the wind diverges above. The wind basically diverges above. Okay, so here you will observe you have various different cumulonimbus cloud rain bands which are getting pushed to the side as more clouds are getting created. In the region of the eye, you have lack of cloud formation. In the region of the eye, the temperature is higher than the surrounding or lower than the surrounding. What do you think? In the region of the eye, the temperature is higher than the surrounding or lower than the surrounding? Very good. Higher than the surrounding. This was a question which was asked in last year's prelims examination. So that is why if you are aware of these basic things, those kind of questions will be much easier to solve. This is the kind of the cyclone where you observe this is your eye, which is tropical cyclones will always have an eye. Temperate cyclones may or may not have an eye. Cyclones always develop an eye. Temperate cyclones might or might not develop an eye. Okay? Now, here, these cyclones will be carried by the permanent wind systems. The permanent wind systems will carry the cyclones wherever they go. Now, here, I will not take you to the details of recurving, etc., but just the basic I will give you. Tropical cyclone is much more devastating than a temperate cyclone. So here, let's suppose you consider Indian landmass, the coastal area at least. Now, if you have a cyclone which is formed here, ideally this cyclone's path should be where? Like this, right? Carried by the trade winds, by the trade winds in east to west direction. Now, if I say that this movement will be impacted by Coriolis force, will that be a correct assumption to make or will that be a wrong assumption to make? Will this entire movement of the cyclone be impacted by Coriolis force? True or false? Correct? Right? So here, as this cyclone moves, any moving object will get impacted by the Coriolis force. So there will be slight bending and it will make a landfall here. Sometimes what happens, let's suppose the ITCZ has reached over the Indian subcontinent. So in that case, the prevailing wind direction, we will study more in the next couple of modules. So the prevailing wind direction is from south to north during the monsoon season. When you talk about the monsoon season, the wind direction over the region of the Arabian Sea, Bay of Bengal is like that. So if you have a cyclone which gets formed here, now this wind system will carry it in this direction and there will be slight curving. Okay, the recurving will happen. So that is why you will observe that across the western coast, when the cyclone gets created, it will hit the Gujarat and Maharashtra coastline. When in the eastern coast it gets created around the region of Bay of Bengal, it will either hit Andhra Pradesh coastline, Odisha, or sometimes even Bay of Bengal coastline. Now, India experiences two different cyclonic seasons. One of the cyclonic season that India experiences extends from end February till June, and then after that, the other period when the subcontinent of India experiences cyclones is in November and December. Why is that? Because during the time of April, May, June, the ITCZ is advancing over India, over the region. The ITCZ slowly and steadily, it keeps on advancing. So as this ITCZ heats up the water body also, or moves over the water body, you have the pre-existing low pressure. So if there is enough heat, generation of cyclone can happen. Over the period, by the end of June and July, ITCZ would have completely lied over the land area. Then you don't have the occurrence of cyclones. Again, ITCZ starts retreating from the month of September onwards. In the month of late October, the ITCZ comes over the water body again. November, water body again. December, water body again. It is in January where it shifts to the southern Indian Ocean. So wherever the ITCZ lies, of generally the region where ITCZ lies, or any region which gets overtly heated up, that is going to experience cyclonic circulation. So cyclonic seasons in India. Seasons in India. Overall, you can say that from the month of April to December, that is where you can experience cyclones, but you have two phases of it. That is so even if you get a statement from April to December is a cyclonic season, that will be correct. But late April to May to June, and then the other one is basically November. In fact, from October itself, October to December. Right? That is the case of a tropical cyclone. Now, whenever a tropical cyclone occurs, you generally experience flooding across the coastal areas. Recently, you had Cyclone Michong, which caused a lot of flooding in the region around the Tamil Nadu coastline, the Coromandel coastline. Now, why does that flooding happen? That happens because of a phenomena which we refer to as a storm surge. That is a surge in the water level brought by a storm. So here, when you observe this, and it is very simple phenomena basically, during the case of a cyclone, we have very strong wind movement, very strong wind movement. Now, that very strong wind movement will be able to drag some significant amount of water inland. Generally, when you have wind movement, you experience wave action, you experience the existence and the formation of waves. But when you have that very strong wind movement, it is able to drag water inland. More water is dragged inland. So here observe, normal high tide would have been up till here. But when you have that storm, in the case of a very strong wind, that because of the frictional drag, it attracts more water, floods the inland areas. Are we comfortable with this? Yes or no? What is a storm surge? So strong water or strong wind movement drags more water from the sea. Because if you think about it, this is the case of the land area. Here you have the water body. Here you have, let's suppose, the water body. Now, whenever you have a wind movement, winds generally will tend to, because they will have some frictional drag, they will drag some water. More strong wind movements, they will drag more water. Eventually, that water will be driven over to the land by the strong winds. So that water is driven over to the land, leading to coastal flooding. Is that understood now? I will answer the other questions at a separate point of time. As of now, is there any problem in this storm surge? Or is that clear? Okay. There is another reason why sometimes in the coastal areas there is a significant amount of flooding action. And that reason is very intense low pressure. So we do know that the atmospheric pressure on an average at sea level is 1013.2 millibar. But when we talk about the cyclone, around the central point of cyclone, you have a very significant low pressure. So imagine a water body. Imagine the water body like this. Now, in this area, if you have a low pressure, the pressure exerted from above is less. What do we expect? Can we expect there will be a slight rise, a temporary slight rise in that area? Rise in the water level ever so slightly? So, because of that very low pressure, the pressure is not very significant, there will be a slightish rise in the water level. So, that is why, as the low pressure travels, as this low pressure travels forward, then that rise is basically also going to move. It is not because of expansion of heated water. It is because purely driven by the case of a low pressure. Intense low pressure means, see, everywhere else there is a pressure of the air acting on the sea surface. Let's suppose in this area you have lifted the pressure. So, not to say that the sea water will start moving up to the sky, but ever so slightly there will be some rise. So, as that low pressure travels over to the land, that rise will be carried over to the land. It will flood the coastal area. Okay, so that is basically the case of the coastal flooding. Prem Kumar, my dear friend, I told you I will answer. Okay, you have now pasted this question. How many times, Prem? 50 times or 100 times? As you said, permanent winds like trade winds lead to the movement of cyclone. That then why many a times we see sudden change in path of cyclones, like from coast of Gujarat to Arabian countries, coast of Yemen. Why will that happen, my dear friend? That never happens, first of all. It can happen that it is expected, the expected kind of movement, let's suppose, is supposed to hit the region of, if you're talking about Andhra Pradesh, it is hitting Odisha. If you're expecting Tamil Nadu, it is going to hit Andhra Pradesh. If you're expecting West Bengal, it will hit Bangladesh. That rightward bend can happen. Having said that, sometimes what you are talking about, this is what, okay. Let's suppose the wind direction here is like this. This wind direction is setting up. Now, if there is a cyclonic development here, it will hit like this, right? Sometimes it can also happen what you are saying in the case of the recent occurring cyclone, which occurred in the case of the Arabian Sea, where it was expected that it was not the expectation, but our media channels, they basically had that conclusion given ahead of time that it is going to hit Maharashtra and Gujarat coastline. So basically what happened at that point of time was, in the region of the Arabian Sea, you had the formation of a cyclone. And this cyclone, it was predicted this will be the path of the cyclone. It was predicted. But if you have a very significant low pressure over the land area here, let's suppose you have a very significant low pressure. Now, in that case, the normal winds, the permanent wind systems, they will get diverted like this. They will be diverted to that low pressure. And that is when the cyclone will hit that area. So it is all carried by the permanent wind system. Permanent wind systems over the northern Indian Ocean, they keep on changing their direction. That is why we experience monsoon. As I told you, when we cover the portion of Indian geography, you will be able to understand it much better. How cyclones hit the Bengal coast. When you have the ITCZ lying over India, that is when, if the cyclone gets created in the region of Bay of Bengal, the winds are directed towards the ITCZ, and that is when the winds will carry it over Bengal and Bangladesh. Why more cyclones develop in Bay of Bengal than Arabian Sea? We'll discuss this after three classes. Not today. We will discuss this particular issue after three classes. In the intervening period, I will keep on giving you various arguments and logics why more cyclonic formation in the Bay of Bengal is observed. Culmination of all of this you have to do on your own by the time that we reach the portion of oceanography. Means intense low pressure leads to storm surge, and also that will be a simplistic argument to make. See, cyclones, Twisha, right now we have not covered the portion of Indian monsoon, Indian geography. All of you are having a doubt why the cyclone moves in a certain direction over India. Just wait for a couple of sessions. We will discuss it in detail. Don't worry. Intense low pressure, basically, that can lead to storm surge as well as the case of a cyclone. Yes. Okay. Now we come to the portion of naming of cyclones. How is it that the cyclones are named? Earlier, you had a scenario where the cyclones would be named very randomly. A cyclone would be named, maybe if it would, earlier it had happened that a cyclone destroyed a boat Antier, and the cyclone was named Antier. So, such kind of random naming was done earlier. Then, in the 90s, people developed a kind of a naming system. That is when basically a naming system was arrived at, where you had a particular process of naming which was followed. This importance of naming was further highlighted during our own experience of the Odisha cyclone. Odisha cyclone of 1999 was particularly devastating. Many of you would not even have been born at that point of time. So ask your older generation, particularly those of you belonging from the region of Odisha. You would still have the generations, older generations would have scars in their mind about the cyclones. Now, presently, the government communication system and the government method or administration's method of communication is not very efficient. So you can think about the condition in 1999 when we did not have a proper disaster relief mechanism or a disaster relief force for that matter. And you had a predominance of kacha houses, the mud houses, they would predominate. Now, in 1999, the meteorologists, they predicted that a cyclone is getting formed over the region of Bay of Bengal about to hit Odisha. Now, as has been the case with our meteorological department, it is not always prompt enough to issue a warning. So there was some delay in issuing the warning. And then obviously the administration is not very efficient in order to transmit that news that a cyclone is coming. But they did transmit that information eventually. They asked people to evacuate from the low-lying areas. Now, generally, if someone from the government comes to your house and tells you to evacuate, what is the tendency? That they are trying to grab the house? They are trying to evacuate us, vacate us? We will not go. There's a resistance. So few people evacuated. Many of them did not believe the government officials. They thought that it is a kind of a scam or something. The cyclone struck. Devastation was caused. Huge devastation was caused. There was floods everywhere in the region of Odisha. The entire state and the entire nation went into mourning. There were hundreds of, in fact, thousands of lives which were lost. Many areas were flooded, bodies floating into the water. If you can only imagine that time's news bulletin, it was horrendous. Meanwhile, as people were recuperating from their loss, they were still counting the dead ones. They were very angry at the government. Regardless of whether the government told them to evacuate or not, eventually, the easy anger is against the government that they should have convinced us to evacuate. They did not convince us enough. Meanwhile, the meteorologists, they found out that there is another cyclone developing, which is going to hit the coastline within the next 7 days. Now, this time, the government was very prompt. Immediately, the administration started issuing warnings that look, the cyclone is going to come, it is going to hit. Now, many of the people, they thought that look at the inefficiency of the government. They are coming with the announcement when the cyclone has already come and passed, and now they are coming with the announcement. Many of them did not believe. Many of them were still outside when that second cyclone struck. Many regions were still flooded when that second cyclone struck. And devastation caused was unparalleled. Overall, Odisha accounted for close to around 10 to 15,000 lives were lost in that duration of 10 days due to the twin cyclones. Now, that further exaggerated the need to have a proper naming. By that point of time, a naming method had been already initiated. So, what is the procedure for that naming? First of all, when a low pressure center is created in the water body, the tropical cyclone warning center that alerts the meteorological department. Now, this tropical cyclone warning center follows that low pressure around. It does follow that low pressure around. Then eventually, you will observe that you have regional specialized meteorological centers which have been established across the globe. There are 6 regional specialized meteorological centers which cater to the naming of the cyclones in their individual areas. So you have RSMC New Delhi, responsible for the naming of the cyclone in the northern Indian Ocean, Arabian Sea, and Bay of Bengal. RSMC Reunion Islands, associated with the naming of the cyclones in southern Indian Ocean. This is under the control of the French Meteorological Agency. RSMC Tokyo, naming of the hurricanes. RSMC Honolulu, naming of the typhoons in this case of Tokyo. Naming of the hurricanes with RSMC Miami and RSMC Honolulu, and then RSMC Nadi. These are the 6 various RSMCs. Now, the Tropical Cyclone Warning Center warns the RSMC. Now, RSMC New Delhi will have its own list of names. How are these names arrived at? So, under the aegis of World Meteorological Organization and UNSCAP, under the aegis of World Meteorological Organization and UNSCAP, find the full form of UNSCAP on your own. Various countries of the northern Indian Ocean, which get impacted by the cyclones in the northern Indian Ocean, they came together. You had 8 countries which came together. 1, 2, 3, 4, 5, 6, 7, 8. Each of these countries gave 8 names. Each of these. So in total, how many names are there? 8 countries gave 8 names. How many names? 64. So you had 64 names. But that naming list was used one by one. Eventually, the last name was used in the month of May 2021 was when the last name was utilized. After that last name was utilized, then what? Then basically, you had a situation where, or even before that, prior to a couple of years prior to that, in 2018 itself, you had a fresh meeting of these countries impacted in the northern Indian Ocean. So this time, 13 countries came together. Saudi Arabia, Yemen, etc., they all joined in. Now you had 13 countries giving 13 names. So how many names that you have? Total 169 names. So one by one, name is picked from the list. Whether a cyclone occurs in Arabian Sea or Bay of Bengal, a name is picked up from the list and given to the cyclone. Okay, so if you take a look at the list, I have given here only 2 columns. Like that, you have 13 columns in that entire list. Observe here that the countries are arranged in an alphabetical manner. Alphabetical manner. Each of them have given their list of 13 names. Each of them. Now, one by one, the name is picked up and the cyclone is named. Okay? One by one, it is named. Now, in this year, in the month of June, you had Biparjoy, then you had Tej, Hamoon, Midhili. The recent one was Michong. The next cyclone which will occur, be it in the Arabian Sea or Bay of Bengal, it will be named as Rimal. The next cyclone which will, the other one is the pronunciation, the list of the pronunciation, how you pronounce that name. Next one will be named Asna. After that, whether it will occur in Arabian Sea or Bay of Bengal, it will be named as Dana. After that, whether it will occur in Arabian Sea or Bay of Bengal, it will be named as Fengal. Like that, the naming is done one after another. Okay? Why only Michong was focused? Only Michong was focused because you have concentrated on current affairs very recently. If you follow current affairs for around 1 year, at least 1 year, you will understand that all of them were focused. Tote made significant news headlines. Biparjoy this year in June made significant news headlines. Okay. What basis the name? So each of the country, they submit a list of names. A list of names they are submitted by each of the country, and that is utilized. Okay. Any particular meaning to that names, any reputation? No. Nothing associated with the reputation. Right? Now, this is the basic difference between a tropical and a temperate cyclone. A tropical cyclone tends to move from east to west. A temperate cyclone, this is under the influence of trade winds. Prem Kumar, I have already answered your question in detail with the diagram. And temperate cyclones move from west to east under the influence of westerlies. Tropical cyclone has an effect on a comparatively smaller area. Velocity of the wind is much stronger in a tropical cyclone. They form only on seas with a temperature of around 26-27 degrees Celsius. Temperate cyclones can be formed both over land and sea. A tropical cyclone doesn't last for more than 7 days. Temperate cyclones can last for 15 to 20 days. Are there more columns? Yes, there are total 13 columns. Column 3, column 4, like that, there are 13 columns. Okay? Right? So that is all for the session here today. And we'll continue this discussion further. Tomorrow, we will have the extra class and then we will continue this further. Ram, if I tell you to learn the name, will you be able to learn 169 names, my dear friend? Do you have the wherewithal to remember 169 names? Then why that question? So we'll meet tomorrow again in the morning and we will continue further. Thank you for patience, and any doubts that you have, please ask it tomorrow. Tomorrow you will have the session from 7:30 in the morning up till around 11:30. That is the session timing for tomorrow. Okay? See you then. Take care of yourself. Goodbye. Thank you.